Hello everyone, I hope you all are doing well. So today is the third session on the OPSC PGT question solving session. Okay, so we are going to solve from question number 20 because we have done till question number 19. So today we will start from question number 20. See, look at the question. What is the question saying? Okay, if psi NLM denote the eigenfunction of the Hamiltonian with a potential V is equal to VR, then the expectation value of the operator Lx square plus Ly square in the state this psi is given is how much? Okay, so I have already solved this question for you. I will just uh, take you through all the solutions. So see, we have given Lx square plus Ly square expectation value we need to calculate. So for this, we know the operator L square and Lz square. We know this. When these operator act on a state, what is the eigenvalue we know? Because Ls square we derived earlier h cross square into L plus 1. L into L plus 1. This is the eigenvalue it will give when it operates on a state, let's say psi. Whereas Lz when operates on psi it will give mh cross psi. Okay, you all know this. When Lz square operate, so it will give you m square h cross square, isn't it? Yes. So I will find out L square minus Lz square. That will be my Lx square plus Ly square. Okay. Now the thing is how to calculate. We have to calculate. Let's first calculate for Lz square. You know psi NLM. Psi NLM. In psi NLM we have n is 2 here in all the three cases, and L is equal to, if you see, L is equal to 1 here. Okay, and what about the, yes, and what about the m is changing, that is m is 1 0 and minus 1. Okay, so I have done a mistake here, let me correct it here. That is L will be 1 here. Okay, let's do this. I have mistakenly write 1 here, so my calculation is wrong here. So L is equal to 1. If I will put, I will get here L is equal to, let me correct this, L is equal to, I will get, okay, let me erase all this. So I will get, what I will get, L is equal to 1. In these cases if I put h cross square 1 into 1 plus 1, so the answer will be 2 h cross square, isn't it? If then I will have to calculate L square expectation value, so here it will be also 2 h cross square. Let me write it for you people. Okay, this is also 2 h cross square, not 6 h cross square. Okay, let me write it. Sorry for the uh, mistake. Okay, so this is 2 h cross square, and this is also 2 h cross square, 2 h cross square. So it will become, I have to erase it all. Okay, so this will become 3 square is 9, 9 into 2 is 18, plus this will be 2 plus 30. So the answer will be 18 plus 2 is 20, 20 plus 30 is 50. So 2 h cross square will be the answer, because 25 is there. So 2 h cross square will be the answer here. Then what about the Lz square? I think Lz square, there is no problem with Lz square. You see, we have m different values for m. So one is 1, 0 and minus 1. So I have to just put it there. So Lz square, there is no mistake in Lz square, only mistake was there in L square. So this will become, if I will correct it, this will become your 2 h cross square. So this will become, let me erase this. Yes, this will be 50 minus 24, this will be 26 h cross square divided by 25. Okay, so my correct answer will be this one will be my correct answer, that is 26 divided by 25. Okay, this is my correct answer. I hope this is clear to you all, guys. I have done a small mistake there because in place of L I have put 2 there, but it will be 1 because as you can see we have psi NLM structure, we have psi NLM. So if I'll put psi NLM, you can compare it. N is equal to 2 in all the cases, L is equal to 1 in all the cases, and M is different in the 3 states. M is 1, 1, 0 and -1. Okay. I think this question is clear to all of you guys. Okay. Then the next one is an electron is in the ground state of a hydrogen atom. The probability that it is within the Bohr radius is approximately equal to what? Okay, we have to find out the probability. So in order to do this question, you have to know what is the wave function, what is the ground state wave function in hydrogen atom. If you will see your book, so you will find out the ground state wave function for hydrogen atom is this 1 upon pi a cube root e to the power minus r by a. Okay, so we need to find out the probability. If you find out the probability, you have to take the limit from 0 to a because the radius is 0 to a. So psi r square dv you can put 4 pi r square dr. Okay, you can do this problem. I guess if you calculate this, then you will get the answer as 0.32. Okay, come to the next question. In next question we have a particle of mass m in 3 dimension is in the potential. The potential is given when r is less than a, we have this 0. Okay, and one more thing is there, its ground state energy is pi h cross square divided by 2m a square. So no, you have to calculate this na? Then you can get the answer. Okay, let's calculate this. Question number 22. Yes, we have the Schrodinger equation. Okay, we have this radial Schrodinger equation as this minus h cross square by 2m d square u by dr square plus l into l plus 1 by 2m r square plus vr ur is equal to EUR. Okay, so we can put the limit here. We have given the potential, so I have put it there. So d square u by dr square, you will get minus k square u, where k is 2me divided by h cross square root. And if you do the solution, okay, you will find out that ur is equal to a sin kr plus b cos kr. Now put the boundary conditions. So if you put the boundary condition is the above solution, so you could get b is equal to 0. So ur is equal to a sin kr. When r is equal to a, ur is equal to 0. So sin k is equal to 0. If you compare the both sides, you will get k is equal to n pi. So E will be your pi square h cross square divided by 2ma square for n is equal to 1. Okay, I have mentioned here. I think this question is clear to all of you. Next, move to the 23 number question. Okay, in order to solve this question, let's read this. If the interelectronic repulsion in helium is ignored, its ground state energy would be how much? Okay. You know, let's take a simplest system, that is hydrogen atom. For hydrogen atom, we have 1 electron only, and for helium atom, we have 2 electrons. Okay, you know this. So for hydrogen atom, we have the energy formula is minus 13.6 divided by n square electron volt. We have Z is equal to 1 for hydrogen atom, so 1 square is 1 only. For helium atom, if I will have to write, so I will write minus 13.6 divided by n square into Z square electron volt. Now for helium, Z is equal to 2, so you will have to put 2 here. Here I have solved this. Minus 13.6 divided by n square into Z square, and in place of Z I have put 2 and 1 is the electron. So E1 will be minus 54.1 54.4 electron volt. Sorry for the disturbance. Now E2 will be similarly minus 54.4 electron volt. So for the total energy for helium atom will be 2 into minus 54.4 electron volt. So that will be minus 108.8 electron volt. So the correct option is D. Okay. Now move to the next question. We have 24 number question. It is asked that the most probable distance of the electron of the hydrogen atom in its 2p state. Okay, remember this. It is asked to find out in 2p state. So you know the probability formula is r square, r of here 2p state is given, so I will write. Okay, what happened, I don't know. Okay, now it's clear, I guess. Okay, yes, for a 2p state we have the probability will be, and the radial wave function will be r2 1 r, so that will be 1 by 2 upon root 6 z a naught whole 3 to the power 2 z r by a naught e to the power minus z r by 2a naught. Okay, you will have to just square it, so square it, so r square, you got this expression, then probability of r will be this. Now for the most probable distance, we know the derivative of the probability will be 0, so you just derivative with respect to r, so you'll get this expression. Now r can't be 0, so this bracketed term is equal to 0, you will get r by a naught is equal to 4, so r is equal to 4 a naught, so the correct option is option number D. Then what is the probability of finding the 2s electron of hydrogen atom at a distance of 2a naught? Okay, if you solve this question, you can also solve this question from this formula. You can get the probability. So I haven't done this because this is similar question to the previous one. So you can solve this, I guess. So let's move to the 26 number question. What is it asked? For a one-dimensional harmonic oscillator, the product of uncertainties del x into del p. So you have to know what is del x and del p for one-dimensional harmonic oscillator. For one-dimensional harmonic oscillator, we have delta x as h cross upon 2m omega into 2n plus 1 root over, and delta p is mh cross omega by 2 2n plus 1 root over. Okay, here it will be whole root. So if you will solve this, you could get h cross by 2 2n plus 1, and if you take 2 outside, so you will get h cross n plus half. So option number A is the correct answer here. Next, the 27 number question. Here the statistical mechanics question starts. Okay, so till the 26 number, it is all about the quantum mechanics. Now the statistical mechanics comes into picture. So the first question is thermodynamic probability of a microstate. Okay, so this is a theoretical question. So the easy one, this one is the easy one. So the thermodynamic probability of a microstate is not the number of particles. Okay, so here the student has done wrong in this option. So the correct answer is number of accessible microstates. Okay, this will be the right answer to this question. And the question number 28, we have Liouville's theorem holds for. It will be for all ensembles, because if you see, we have three ensembles. One is microcanonical, okay, and second one is canonical, and the third one is grand canonical. In all the cases, if you see, the constant term is V is always there. Okay, so first one, for microcanonical we have EVN, for canonical we have TVN, for grand canonical we have mu VN. Okay, so you see V is in all the cases. So the Liouville's theorem states that the phase space volume remains invariant. Okay, phase space volume remains invariant. So for all the cases, the volume is invariant. So all ensembles will be the answer. Okay, 29. Let's come to 29 number question. So Boltzmann relation between entropy S and probability omega is how much? Okay, this is a direct question, so the you know the answer. S is equal to k log omega. So this is the correct answer, option number C. Let's come to question number 30. In question number 30, we have asked, in microcanonical ensemble, a system A of fixed volume is in contact with a large reservoir B. Then A can exchange neither energy nor particles with B. Okay, the correct, you have to know in microcanonical ensemble, what do we mean by microcanonical ensemble? If you see microcanonical ensemble, we have EVN as the parameters, the thermodynamical parameters. So we have, this is a isolated system. There is neither the exchange of energy, neither the exchange of mass is there. So mass means the particle exchange. So there will be no exchange in energy, no exchange in particles with B. So option number A is correct. So then it is the direct question. In a canonical ensemble, what happens? In canonical ensembles, we have TVN. So energy is only the exchangeable thing here, but particles remain constant in both the systems. So the correct option is the temperature and the density are constant. So what do you mean by density? Because you see, density is how much? Number of particles per volume. Particles remains constant, only energy is variable here. So the temperature is also constant. So the correct option is the temperature and density are constants. Okay, I think for today, okay, let's solve one more question here. The members of canonical ensemble can exchange thermal energy and work with a reservoir. That is, they can interact only thermally or only mechanically as well as thermally with the reservoir, none of the above. So if you see in canonical ensemble, we have energy is only exchange. Energy exchange means we can exchange the mechanical work done. Okay, so I guess for me, 32A will be the correct answer. I don't know the exact answer, but my instinct says that A will be the answer, but I will say once the answer key is out, so we can check it. Okay, so for now, option number A is the correct answer for my from my side. Next, the grand canonical ensemble is a collection of essentially independent assemblies having the same. Yes, this is, I have already told you about this. TV mu will be the correct answer. So for today, we'll stop here. So in the next session, we can start from question number 34. So if you like the question solving, you can do subscribe. You can share it with your friends. Okay, thank you for all your support. Okay.